And welcome back to Mr. Gregoris Math. Today we're taking a look at box and whisker diagrams. No, not this cute box with whiskers, but a box and whisker diagram that demonstrates single variable data, specifically the distribution of single variable data. And so what we end up having is a box that's in the middle and these two whiskers that extend off to the side. Now this is a median-based version of displaying data, and so we actually have a line here that indicates the median. And this box demonstrates the closest 50% of data to the median. It is on a scale, so that means that the bottom 25% below the median is further stretched out than the top 25% above the median. So it gives you a sense of how the data is spread. Now this box contains 50% of the data, that's the middle 50%. This top portion from the whisker is the top 25%, and this bottom portion to the whisker on the left is the bottom 25%. Some other measures that are going to be important in helping us define this are our minimum and our maximum. We'll also need to figure out where our box starts and ends, and that's at our Q1 values and our Q3 values. So we need to find these 5 numbers from our data set so that way we can draw a box and whisker diagram. And then afterwards, we'll check using our interquartile range to figure out if there's any outliers, either above, as indicated with the star, or below, as indicated with the star in the other direction. So we're going to do the work first in finding all of these values and classifying outliers, and then we're going to go ahead and draw our box and whisker diagram. I've got a data set here for us. So our data set has the numbers from 1 to 48, and there's 13 pieces of data here. So my first thing that I have to do is break my data into 2 pieces. So the first piece is going to be determined by the front 6 pieces of data up to the median. So 1, 2, 3, 4, 5, 6, and that means that my 7th piece of data here is my median. You can see this breaks it into equivalently 2 groups. I've got 6 before, and I've got 6 afterwards. So that's my median or my Q2. Now I have a minimum value of 1 and a maximum value of 48. That work is quite easy to find. But I suspect maybe that this 48 might be an outlier. We'll check that later. I don't suspect this 1 is an outlier, so we will show why we won't check that, but we're not too concerned about it at this point. Now I need to take each half, so the half before the median and the half after the median, and break them in half to find my values of Q1 and Q3. So I look at my first 6 pieces of data, and I say the middle is in between 4 and 5. And I take the arithmetic average of 4 and 5. So 4 plus 5 divided by 2 is 4.5. And I go and do the same thing with my last half. So the middle would be in between 20 and 21. So Q3 is going to be the arithmetic average of 20 and 21, or 20.5. Now that I have my minimum, my median, Q1, Q3, and my maximum, I can go ahead and consider whether or not I have outliers using my interquartile range. So my interquartile range is the difference between Q3 and Q1. So in my case, that works out to be 20.5 minus 4.5, or 16. Now to check whether or not 48 or 1 are outliers, I have to take Q3 and add 1.5 IQRs to it. This is the largest a piece of data can be, the furthest ahead of Q3 it's allowed to be before we call it an outlier. So let's figure out what this number is. In our case, that's 20.5 plus 1.5 times my IQR, which is 16. Now 1.5 times 16 is going to be 24. So we'll have 20.5 plus 24, which is 44.5. So that means any number above 44.5 is going to be an outlier. Hey, look, 48 is above 44.5. That means this is an outlier, and my new maximum becomes 21. So I'm going to adjust where my whisker ends and indicate my outlier with a star. So this 48 is going to be indicated on my diagram with a star. Now I could do the same to check below quartile 1, because the way to check for outliers below is Q1 minus 1.5 IQR. But when we evaluate this, what we're going to find is it's going to be 4.5 minus 1.5 times 16. And it's very quickly going to end up being a negative number. And since we don't have any negative numbers in our data set, we can confirm that we're not going to end up having, I guess this is going to be negative 19.5. Negative 19.5 is way to the left of negative 1. So there's going to be no outliers below. There's one outlier above and no outliers below. It's now time to go ahead and start drawing our box and whisker diagram. So I have to apply a little bit of a scale. What I like to do is I like to think of a nice round number below the minimum and a nice round number above my largest data value. This would have been the maximum, but since it's an outlier, it's now my largest data value. So I think those numbers are 0 and 50. So I'm going to start at 0, and I'll go up by a common increment in tens. So that's 10, 20, 30, 40, and 50. And I'm going to draw my box and whisker diagram just slightly above this. So my first thing that I'll do is I'll draw a mark at 8. That's my median. So 8 is about right here. Then I'll draw a value at 1. That's going to be my minimum. So 1 is about right here. I'll draw a value at 4.5. It's just a little bit below half. And I'm just using an approximation of scale, just because I care about showing the distribution, but I'm not too concerned with having a perfect scale the entire way along. And Q3 was at 20.5, so that's somewhere out here. And my new maximum is at 21, so that's just past it. So I have my 5 marks now that can help me to draw my box and whisker diagram. My middle 3 marks are going to be connected with my box, because that's my middle 50% of the pieces of data. So half of the data is contained between 4.5 and 20.5. That's that half right there. And that's demonstrated in this box. Of course, the median is closer to the front of that half. Then I'm going to have whiskers. My whiskers extend from the box out to the minimum and out to the new maximum. And I say the new maximum because I'm not including my outlier when I draw my box and whisker diagram. I am going to include my outlier at the end with a star all the way out here to show that there was one way out wacky piece of data far above my whisker. Had this not been an outlier, had it been at 44.5, I believe was the number, yep. Had it been at 44.5, I would have had my whisker end right there at 44.5. But because it didn't, the next closest piece of data in was 21, my whisker has to end there. So this is how to draw a box and whisker diagram with a 5-number summary and using outliers. I hope you had a great time. Don't forget to hit like and subscribe, ring that notification bell, and check the comment for the link to the merch store.